See some attendees signing in as we speak, which is great.
Cool. We'll give everyone a minute or two just to dial in and we'll get kick-started. Cool. If you're happy to get kick-started, John, I'll do a quick round of introductions before we get going. So welcome to everyone on the thread. Just wanted to introduce myself quickly. So I'm the AWS representative on this call. My name is Josh Bohr, and day-to-day I'm one of the startup account managers. So I just wanted to jump on the call quickly just to introduce, first of all, John at Scale Factory and the WellArchitected Review webinar that we're all here for. But I just wanted to run through a quick overview of the Startup Account Manager and the resources that you have available over on our side in these sort of unprecedented and unsure times. First thing I'll say is if you're not sure who your account manager is at all, please do feel free to reach out to anyone at AWS who will happily redirect you, or you can click the Contact Sales tab on the AWS website. So I'll just give you a quick overview before handing over to John. So think of your AWS account manager as a window into the wider AWS business. So we can assist with both technical, commercial queries, usually of the deepest strategic conversation variety. So if I start on the technical side, we'll break it down into sort of two pillars. You've got technical and commercial. Whilst the account manager role is not necessarily overly technical, we do have experience working with a wide variety of customers, and so are able to answer certain technical questions and product questions. But anything deeper, we have a fantastic solutions architecture team, and we call them SAs for short. So SAs can be brought into calls for strategic conversations, service-specific questions, reviewing your architecture, or if you've got a migration or any other desired path that you want to go down, we can make recommendations to ensure you're set up for success. Now, this is a hands-off keyboard role due to the self-service model, but if you need a bit more support and some hands-on keyboard and more deeper consultancy, we have a wonderful partner network available, such as John at Scale Factory, who I'm sure will introduce himself shortly. On the commercial side of things as well, so our role as startup account managers is to ensure our startups are set up for success as best as possible. And we have a number of interesting growth programs we have available to offer startups to offer you guys as much support as possible in these challenging times. I won't go into them in too much detail because they're very specific depending on your company and what you do. But I would really encourage you to reach out to your account manager to discuss these in further detail. Outside of this, we host regular events, both virtual and obviously once this is all over, we'll be back to face-to-face. And it covers a range of topics, technical topics from hearing from how customers grew and scaled on AWS, how they built their MVPs. But we also cover more business-focused content, such as building your perfect pitch deck and selling to investors. To hear more about these programs and events, please do reach out to your AWS representative. We'll be happy to chat through any of the above and send through details for our programs and upcoming event schedule. That's all from me. I'll pass over to John at Scale Factory now.
Thanks, Josh. Morning, everyone. So we've got 23 people on the session already this morning, which is great. I'm just going to share my screen, and then we can get started with some introductions and so forth. Okay, you should be able to see my screen now. I'll ask Steve to confirm that for me.
Yep, I can see it.
Great. Okay, so we're ready to go. Cool. So just a bit of, I guess, webinar housekeeping to start with. I'm presenting from Keynote on the Mac, which covers almost all of the controls that Zoom provides, aside from the question and answer window. So as we go through today, if you've got a question that comes to mind, please hit the Q&A button at the bottom of your Zoom screen and use the window that pops up to ask. If it seems like something that I can answer sort of in flow, I'll do that. If it looks like something that might be better off answered in detail elsewhere, then we can either defer it until the end of the session, where we'll have a sort of dedicated Q&A section, or I'll ask Steve to cover it in the chat. The chat is open. You can chat with each other as well as just with us. I've enabled that permission, so do feel free to introduce yourselves to each other and use the chat as we go along. The webinar itself is being recorded. The recording will be made available to you. I think I pressed the right buttons in Zoom, which means that you will get an email with a recording link once we're done. So people who sign up to the webinar in future will be able to get at those recordings as well. The chat, I believe, is logged along with the recording, so that'll be recorded for posterity. Do bear that in mind. I will make slides available to anyone who's interested as well after the fact, so don't feel obliged to take copious notes as we go. You'll have access to a link where you can download those as well. The content itself is going to be about an hour long, so we'll probably be sort of over the hour that you might have originally sort of planned for this. If that's the case, please do feel free to drop out if you have other things to do, and come back and watch the recording another time if you like. Otherwise, kind of assume we'll be here for about an hour and 15 or so. Steve's going to be around to answer questions at the end as well. One other final bit of housekeeping: I am sat right by the front door of my flat, and it is entirely possible that the doorbell will go whilst we're on this call. If that is the case, I will just sort of say so and go and answer it in the meantime, and pick up whatever's being delivered. But the chances of that are 50-50 at this point. I think the postie often arrives around this time, so sorry about that in advance. So we're going to be talking about the importance of being well architected. I think some of you have been made aware of the WellArchitected program in general. We're going to talk about it in some amount of depth, and let you know some of the ways in which you can engage with that program, and how we can help you engage with that program. First up, you're probably wondering who the hell I am. So I'm the founder and CEO, CTO of the Scale Factory. I've been doing hosting and infrastructure things for about 20 years at this point. So I've been around the block. I've been around sort of prior to public cloud. Spun up my first EC2 instance back when they were first available, but have sort of been fully all in on AWS for the last sort of five years or so. My sort of area of interest, other than infrastructure, is DevOps. We came up as a DevOps consultancy sort of from 2009 when that was first becoming a word. So I think I'm reasonably well qualified to talk about this stuff. Hopefully you agree as well. We as a business, the Scale Factory are an advanced consulting partner within the Amazon Partner Network. That is the doorbell. Excuse me just a second. There we go, exquisite timing. So we're part of the we're an advanced consulting partner in the Amazon Partner Network, and we joined the WellArchitected program as a launch partner. So when that was first getting started, we were invited by our partner development manager to get involved. We were also in the process of being awarded the SaaS competency, which is due for launch this week. Next week, and that demonstrates our kind of abilities within the SaaS and ISV market. So if you are a SaaS vendor, or you're selling software in a SaaS model, we have particular expertise and history in that we can bring to bear. We're also a Kubernetes certified service provider. So if you are Kubernetes users, we have people on the team who are certified and capable within that ecosystem. We're also a G-Cloud supplier. So if you are selling to public sector, or you are yourself a public sector client, we can sell our services through the G-Cloud framework as well. And down the bottom there, you see we are fully certified. We have within the team of 19 people, we've got 50 AWS certifications between us, which is pretty good going. In terms of our involvement in WellArchitected, we're one of the leading partners worldwide in that program by total number of reviews. Since April 2018, when we joined the program, we've reviewed over 200 workloads. Actually, that number was from a couple of months ago. It might be a little out of date. You can book with us a WellArchitected review. Doing so will unlock some funding credits. I'll talk a bit more about that later when it's a bit more apparent what the value of that is. as you see, we've been doing this a while. We're probably the people you want reviewing your infrastructure for you, based on that level of experience. And WellArchitected is really very highly embedded in our consultancy process. It sort of informs pretty much everything we do these days. Most of these reviews were performed with startups and SMEs, so very relevant to this audience, I think. And hopefully we can bring some of that value to you as well. We like to put our people first. Here's the team. As I say, we're 19 people today. We're headquartered in London, but we've always been a remote organisation. So although we've got an office for meetings and sales conversations and so forth, many of the team work remotely from home or from co-working spaces near where they are. So this whole pandemic situation hasn't come as a massive shock to us, really. We've been able to continue business as usual pretty much, with the exception of some of our in-person stuff now going remote. We've worked across a range of clients over the last 10 years, 11 years. You'll recognize some names there. Organizations like Expedia and ITV are obviously our sort of big brand name enterprise clients. We've also worked in SMEs and startups, so we're very comfortable in the startup world, having helped a number of businesses build their first infrastructures and then scale those as they grow. We're also very happy across all business areas. So you've got clients here who are in the e-commerce, the entertainment, media, finance, healthcare, and automotive, like all of those kind of things. All those businesses have the same sorts of concerns in the cloud, just with maybe different parameters dialed up to 11. So in the sort of healthcare sector and the finance sector, for example, security is much more of a concern, and we're really happy working within those sort of compliance regimes that those businesses have to conform to. So today's agenda, we're going to talk about what WellArchitected is. When we talk about what a WellArchitected review looks like. WellArchitected is split into pillars. We're going to do a brief overview into each of those 5 pillars, and in that, I'm going to talk about common review findings, so things that we've seen as we've reviewed these workloads. Things that we see repeatedly that as useful information you might be able to take away and kind of avoid making the same mistakes while you're building your own platforms. So let's get into the meat of it. So what is WellArchitected? Well, WellArchitected was sort of started within AWS by the field solution architects in that organization. And these guys, obviously, like us, are traveling around, meeting lots of teams and seeing patterns and understanding how people are making their design choices in their infrastructures. And they've seen some of those things emerge frequently as good practice, and have codified that good practice into this framework that they've then shared initially internally, but now sort of more broadly with the partner ecosystem, and also sort of publicly on the AWS website and in the console. In 2018, AWS opened the review process and the tooling to partners. Within Amazon itself, the solutions architecture team were only managing to talk to about 8% of workload. So it was clear that they were unable to sort of scale their personnel to review everybody's use of AWS, and their hope was that by making it available to the partner ecosystem, that could be made a little more available, a little broader. It's sort of a platform agnostic framework. There's nothing specific in the documentation or the review tool that implies AWS is being used here. So you can actually use the review tool to review non-AWS workloads, particularly maybe in advance of a migration to AWS or something of that nature. So the questions are useful and broad in a sort of non-AWS sense as well. But it is most valuable if you are an AWS user, because a lot of the sort of examples that are given in the documentation refer to AWS services. And the way that when we run our reviews, we are talking about AWS specific service recommendations. But I guess I don't need to sell the platform agnosticism of this to you, particularly because you are already AWS customers. Well done, good choice. So the WellArchitected framework sort of made up of two main components, really. There are a set of white papers, and these are PDF documents on the AWS website that talk about design choices and how to make design decisions about your platform, and a review tool, which is it's in the console. It's something you can go and look at today. It's not in all the regions. It's definitely in the regions that you're probably using as a UK consumer. And the review tool contains a number of questions, and the questions have a number of sort of multiple choice answers that you can choose from. At the end of that process, you get a score and a set of recommendations for improvements. But we'll talk a bit more about the review itself in a little while. As I mentioned, WellArchitected is split into 5 pillars or areas of concern. We talk about operational excellence, we talk about security, reliability, performance efficiency, and cost optimization. We find that in different businesses, different organizations have, I think of these in a different weighting. So a compliance industry such as fintech or healthcare will obviously think more seriously about security. Maybe in the startup realm, you're probably concerned about cost optimization a little more than the enterprise might be. But these concerns cross-cut pretty much everything that we do everywhere, and so they're a sort of sensible way of looking at the world. And so there's a white paper for every pillar in the documentation, describing best practices around achieving good results within that area. The other way that WellArchitected is divided out is into lenses, and the lenses are ways of looking at your workload if it is a specific type of workload. So the serverless applications lens is currently built into the online tool already. The other 3 are not yet, I don't think, but they are all documented. And each of those lenses provides another set of questions in each of the pillars. And I'll show you how those break down in a sec. So if you're using serverless, or you are an IoT startup or something that fits into one of those lenses, then the lens is a good way of getting very sort of workload specific advice and guidance. In terms of how you'd use WellArchitected as a team, the biggest win we see is using WellArchitected for gap analysis. So kind of looking at what are you currently doing today, what is not quite right about what you're doing, and how will you get from where you are now to where you need to be. So it sort of helps us with road mapping and helping teams decide how to spend their time in terms of infrastructure. It's great as a teaching tool, at least for us as a consulting partner. When we run through the review process, it's a really good opportunity for us to help teams better understand the platform, learn things about it that they didn't previously know, and learn from our experience as a consultancy who touched a lot of infrastructure. And in larger organizations, we've seen teams use WellArchitected for alignment. So if you have multiple delivery teams all producing applications across a business, then using WellArchitected to essentially benchmark the practice of those teams against a common business standard, so that people can move between teams and know that their infrastructures are going to look more or less the same as the last thing that they worked on. So what's a review? The review itself contains a number of foundational questions. Basically, as I mentioned, questions about the design decisions that you've made, or the ways that you plan your changes and so forth. It takes about 4 hours, at least in a partner-led review. So if we're sitting with a client and working through the review tool, then it takes around 4 hours. That 4 hours kind of goes, we'll sort of dive in and out of specific subject areas and maybe sort of stray off the path of the questions a little bit, just to give you a bit more sort of clear value than just following the tool yourself. And the review is qualitative. Nothing is sort of measured against a scale. It's very much kind of, are you doing this how well are you doing that? So it's not sort of, you can't really compare two companies' reviews with each other, because there's no real way of sort of measuring the operational excellence of an organization particularly. So it is very qualitative, not especially scientific, but that in itself makes it a more useful kind of starting point for conversation, I think, than the sort of deep measurement of practice. The way that the tool breaks down, there are 46 questions in the WellArchitected core. So we will always cover 46 questions as we go across the 5 pillars. And if you are yourself a user of one of the lenses, so if it makes sense for us to get into your serverless conversations, then there are another 9 questions to add to there. If you're an IoT user, then we'll add another 35 questions, the majority of which in security, obviously, because the IoT, the S in IoT stands for security, as we all know. And if you're a machine learning workload, then there are another 21 to add. The machine learning lens, incidentally, was added, I think, this week. So this is a sort of hot off the presses. I haven't had a proper look at it yet, other than to see how many questions there were, so I can fill out this slide. And the questions look a little like this. This is the first question, the ops pillar, asking how do you determine what your priorities are? And there are a number of boxes you could tick here, and you tick one or many of those boxes, and each tick in those boxes will give you a score. So depending on what you tick, you will either get a well-architected mark, a needs improvement mark, or a critical finding mark. I appear to have duplicated this slide, so we'll skip over that, and then dive into the pillars themselves. So the operational excellence pillar is always the first up in the review, and this pillar covers, for the most part, priority setting, so deciding what to spend your time on and how. It covers the software delivery lifecycle, so getting your code from developer laptop into production and via sort of tests and so forth. It's concerned with reduction of risk. So looking at within that software delivery lifecycle, what opportunities are you taking to reduce the risk of introducing defects into your workload? It's concerned with monitoring and telemetry, so understanding and visualizing how your workload is performing, what resources it's using, that sort of thing. How execution threads through your code path if you're using Lambda and that sort of thing. It talks about documentation, so whether you've written runbooks, playbooks, written down kind of what your infrastructure looks like and how to operate it. And it's also concerned with continuous improvement. So how do you learn from failures on the platform? How do you kind of put that feedback loop into your business so that you're always learning from things that go on in your operational landscape? And so when they talk about software delivery lifecycle, we're primarily looking for, are you using a continuous delivery pipeline? Are you passing code changes through a pipeline, exercising it with tests, deploying it into a test environment, and then promoting that stuff into live? Are you doing that in a continuous fashion? Can you do that automatically using scripting and tools, or are there sort of manual steps involved? And that's sort of what we're looking for in that arena. And this isn't really just about getting a good mark in the well-architected box. If you look at the research provided by the State of DevOps reports, this is from 2019. State of DevOps report is it's an information gathering exercise that's run sort of every year for the last 6 years or so. Initially in combination with Puppet Labs, but now run by a group called DORA, the DevOps Research and Assessment organization, who are now owned by Google. So this is the sort of the only piece of statistically valid peer-reviewed research about operational practice out there. If you've seen a book called Accelerate by Nicole Forsgren, also Jez Humble and Gene Kim, although I think Nicole's done the real hard work there because she's the scientist. The research they've done asks teams about their operational practices, and then groups the results of those into sort of groups of teams that are elite performers, high performers, medium performers, and low performers, and correlates particular practices against a performance level. And so they've identified that an elite performing team, which is really what you should all be aspiring to be, is able to deploy software multiple times per day, basically on demand, has a lead time for changes. So code takes less than a day to go from a developer's laptop into production. The time to restore service in the event of an incident, the mean time to recovery is lower than an hour, and the number of the percentage of changes that cause failure is less than 15%. So that elite performing teams perform that way, and those elite performers are correlated with use of the cloud. So the fact that you're on AWS already means that you're partway there. Use of automation, use of CI tooling, and a number of other things besides that. So if you're at all interested in sort of improvement of your operational practices, Accelerate is a really good read. If you are yourself in an organization where you need to convince people of the benefit of investing in those sorts of practices, Accelerate is the only kind of legit research in that space, which means that these days, when we first did DevOps, we were kind of relying on the dogmatic idea that this just made things better. Dora provided us the means to quantify that and demonstrate beyond doubt that these practices are helpful. Monitoring is another correlated practice, correlated with elite performers. And when we're talking about monitoring from a well-architected perspective, we're talking about monitoring at a number of different tiers. So monitoring what your users are doing. So things like Google Analytics or Amplify, or those sorts of things where you can see what users are actually doing with your app or on your site. We want to be looking at application monitoring. I've put red in brackets there. That's rate, error, and duration. So what's the rate of requests against the platform? What percentage of those are errors? How long are those requests taking? So actually kind of measuring at the API layer or the HTTP request layer to see exactly how the application performs and how many errors it's throwing. Infrastructure monitoring, so things like resource usage, that sort of thing, the kind of stats that you get from CloudWatch and so forth, and then making those monitoring data available in dashboard form for general consumption. One of the concerns of DevOps is sharing, and sharing data amongst teams is one of those areas. We're also concerned with centralized logging in the operations pillar. So building structured log data from your requests. So not just sort of spitting out lines of text, but kind of constructing JSON format log items so that a computer can parse them, and then you can do interesting things with the tools around that. It's important to add identifiers to those logs so that you can identify a particular transaction or a particular user through the request chain, and again making those pieces of information available through a dashboard of some kind, which can then be augmented by representing events on that dashboard. So a kind of a vertical line in the graph where you've rolled out new software or you've made some kind of operational change, so you can go back and correlate changes in logging or monitoring data based on the things that you did to the platform that may have caused those changes. So the second pillar in WellArchitected is the security pillar, and again from the Accelerate book or from the DevOps research, we've learned that elite performers build security in. So I have another webinar that I run occasionally called Architecture for Security, which is essentially 90 minutes of how you can secure infrastructure. So there's a lot of stuff to get into here that I won't get into in loads of detail. But the main premise of that talk is that you sort of have to think about security as you design your platform. You can't really paint it on afterwards. There are a couple of things you can do in that space, but unless you're thinking up front about security and building it in, you're probably going to have a bad time. That's proven out by the State of DevOps report data from 2018, where they looked at security, I think, for the first time. The main areas that WellArchitected covers in terms of security are identity and access management, so identifying users and groups, roles, particular services, and then controlling what resources those principals have access to. That's all in the sort of IAM realm. And if you and your teams don't understand IAM, that's a really good place to start, because it's everywhere, and it's absolutely foundational. We frequently see problems with IAM setup in organizations that we review. Detective controls are how you can see whether or not you have had a security breach. So there are a number of products like Guard Duty and so forth for examining your infrastructure on a continuous basis and highlighting to you, alerting to you when there may have been some kind of security incident happening. Infrastructure protection, which is about preventing those incidents. So things like security groups and firewall rules, web application firewalls, those sorts of things, preventing attacks before they happen. There's also data protection, so thinking about classifying your data and looking at what you've got in terms of personally identifiable or sensitive data, and treating that data differently from more general data, controlling access to it so that your human users who don't need access to sensitive data cannot access it, also can't get at the backups of it, those sorts of things. And incident response, so in the event that something happens to your platform from a security perspective, what do you do about it? How do you respond? How do you protect your assets? How do you perform forensics to understand what happened and learn from it? As I say, I've got a huge slide deck on security in general. This view is the AWS shared responsibility model. It's important to understand that whilst AWS do provide a number of things for which they undertake the security, there's a lot of stuff that you should be taking care of yourselves as well. So the stuff in the orange boxes at the bottom of the screen there is AWS's problem. Essentially, they're responsible for security of the cloud. They are securing regions, they're securing your RDS databases and so forth. But you as a customer need to secure your applications yourself. You need to make design decisions that provide appropriate encryption controls. You need to classify your own data. You need to be managing your own network protection, that sort of stuff. So it's not sufficient to be on AWS and assume that you are secure by default. There is work to do in that area, and in some cases quite a lot of work. So please bear in mind that you are responsible for some of that. In terms of our review findings, this is the 11th question from the security pillar, which asks how do you respond to a security incident. 75% of the 200 workloads that we reviewed had a high risk in this issue, which is to say that those workloads, or the teams running those workloads, do not have an adequate mechanism to respond to security incidents. You can see that if you look at the right hand side, then the percentages of the number of those who tick those boxes. So only half of the organizations sort of know who would be involved in responding to a security incident. Only 3% of those 200 workloads actually do anything around rehearsing security incidents, so running game days and sort of trying out what would happen in the event of security incident, and nobody is automating the containment of a security problem. So this is a massive area for improvement across the board, and is sort of generally true. But what we found when we're reviewing these workloads is that teams are generally good at building infrastructure, but generally pretty bad at knowing how to respond to things when they go wrong. There's a very sort of happy path, positive mindset where everything's going to be fine. Very few teams really are thinking about failure models and working towards being able to respond to those and rehearsing those responses. And the type of incident we're talking about here is an EC2 instance getting owned by an exploit in a framework that allows remote code execution, for example. We might also here be talking about S3 bucket negligence, so accidentally making data public that shouldn't be, or API keys that are accidentally made public, which is more common than you'd like to think. One of our clients had an incident where a person leaving that organization had checked their dot files, their config files into GitHub, into a public repository as they left, thinking that they just take their their Vim setup and their other the setup of their tools. They actually accidentally checked in their API keys for the Amazon platform, which were scoped as administrator keys, which was also wrong, and they ran up a large bill with people crypto coin mining on instances that have been started using those keys, and they got off lightly. Bits of that, some of that money was refunded after we had a conversation with the account manager, and they could have been worse off. That account contained all of their data. If that particular bad actor had decided that deleting S3 buckets and RDS databases and backups was the thing that they wanted to do instead of mining crypto coin, that business would have been genuinely screwed because they would have lost all of their data. So there's a lot of I don't want to sort of scare anybody unduly, but I think you should be at least a little bit afraid of what could happen from a security perspective to your infrastructure. And obviously these are things that we can help you with if you yourself are concerned about things in that area. Data classification is another really lax area. This is the third. So I've taken the reviews that we've done. I've identified the common high risks. This is the third most popular high risk. If popular is the right word. 75% of workloads don't do any data classification, and in fact, only 60% of those know what their classification requirements are. Data classification is important for GDPR reasons, if nothing else, and you will all be bound by that, I suspect. If you're in a more dealing with data about children or healthcare data or anything that involves personal data at all, data classification is going to be important to you, and you need to stay on top of this stuff. So 23% of teams are not doing anything around data classification, which is kind of worrying. So in general, teams need to do better around security. We find people are not patching stuff regularly enough. That's if you're running EC2 instances or anything with an operating system, you do need to be keeping those patched, and that is your responsibility. It's boring shit janitorial work, but it is an important thing to do. The majority of I think the OWASP top 5 breach list, the highest cause of security breaches is lack of patching, essentially. Limited data classification, please do look at that. Most teams are pretty mediocre at human access control. Most of you today probably have administrative rights over your AWS accounts. Most of you today probably don't need those on a day-to-day basis. There are ways of working around that and things that you can do to limit the scope of your access until you need it the most. Generally speaking, teams are not doing good programmatic access control, which means that they're not using features of the platform that allow them not to have to bake API keys into application code or config. That's definitely something to look at if you're in that boat. In general, we've seen low adoption of security monitoring tools, even the ones that are really easy to turn on with a click in the console. We're not seeing huge amount of guard duty or CloudTrail usage, and that's an area for easy improvement. The third pillar is reliability. The main areas that this pillar is concerned with are sort of foundational reliability. So how you design your network and your service limits to to hit a particular reliability requirement. And from then on, it's about change management. So elasticity is a big part of the reliability consideration. Can your workload, your compute workload, change shape to match the demand of your customers appropriately? And where you are making your own manual changes or your own sort of automated changes, is there adequate change control around those, adequate safety to ensure that those changes will not cause an outage of some kind? And also failure management. So DR planning is the main sort of thrust of this. Are you thinking about backups and where those backups go, how you would restore them? Are you practicing those backup restore mechanisms? Are you designing for availability? Are you thinking about failure domains? Are you copying data into other regions if you need to be? Those sorts of considerations. We tend to find that organizations are okay at this. Most teams are pretty good at designing for at least reasonable high availability, if not necessarily the highest they could go for. And availability design, we're thinking about clustering and failover. So using auto-scaling groups, or if you're building your own data storage services on EC2, making sure that they can fail over between availability zones, choosing RDS databases that are multi-AZ, that sort of thing. Are you doing auto-scaling in your compute nodes? Most teams are doing a reasonable good job of that. Running in multiple availability zones, and if necessary, in multiple regions. Caching, so building a caching layer in front of services that can take that, so that if the service behind it fails, you're still able to respond to some requests, possibly with stale data. And designing your workflows and your applications to be asynchronous, so using queues to offload longer term processing jobs, so that in the event of a queue processing failure, those jobs will just sit on the queue and not fail, but then can start being processed again by adding back or solving that problem, and providing, in the case where you're building distributed systems, thinking about back pressure and circuit breakers. So back pressure is where if your service sees some kind of problem downstream, which means that it can't itself respond to your request, serving up information in its response that allows the service calling it to know to back off or wait until a bit later, or maybe try again in a minute or something like that. And circuit breakers kind of turning off particular bits of functionality in the event of failure, so that rather than taking the entirety of your application down on one type of failure, maybe bits of it can keep working, and you circuit break the broken stuff and provide a better sort of degraded experience for the user than they might otherwise see. Planning for failure is really about thinking pessimistically, so building a list of potential failure scenarios, and then understanding how your platform will react to those scenarios. One good way of doing that is a sort of tabletop game day exercise, where you enumerate all the services that you have, and think about the ways in which they could go wrong, and then sort of talk about how you might go about knowing that failure had happened, or remediating that failure in some way. You might choose to mitigate some of those failures, so actually make changes to prevent those failure modes, or it might be that you decide that they are not worth the engineering time because of how infrequent they are, and you might document how to solve those instead, and use those to inform your run books from the operational excellence pillar. And then only once you've actually thought about it and made some changes, you think about live failure injection. So you may have heard of Chaos Monkey. You might have heard of a company called Gremlin who do something similar, which is essentially live failure injection into running sites. So shutting down services, degrading network performance, dropping data, that sort of thing. Those are mechanisms for testing your response and sort of testing your hypotheses about your ability to respond to failure. Many teams, when faced with the idea of planning for failure, jump straight to that option because it's a tool they can install. If you install and run Gremlin against your application and you haven't done anything to mitigate its impact, all you're going to do is kill your website. There's no two ways about it. So you're better off planning for failure and mitigating some of it, and then using those sorts of tools to continuously test whether or not you are still mitigated in the way that you think that you were. Just running those without any kind of pre-planning is a recipe for disaster, essentially, and you don't really want that. This is an example of the type of tabletop stuff that we've done as part of a exercise with a client. This client was gearing up for a large-scale marketing launch of their car insurance, sort of a car purchase website, and they were doing a lot of stuff with Lambda. They had some SES in there. There was bits of RDS. It was a modest infrastructure. There wasn't a huge amount there. We took about a day, I think, maybe 2 days to work through each of their components and consider the failure cases of each of those. You can see we mitigated some of those things. We wrote runbook actions for some of them, and in some cases where we didn't really know how the application would behave under a circumstance that we'd identified. We raised tickets to go and look at that in a sort of future dev sprint and understand it. So the process here is formulating a hypothesis about how your application would behave in the event of a failure mode, and then testing that hypothesis in some fashion, and mitigating it if possible. So the sort of notably bad reviews that we found in this area is most teams are not really testing for resilience. You can see 73% of teams are conducting root cause analysis and sharing results. So in the event of things failing, people are generally looking into it and understanding why. But there is very little pre-planning or anticipation of potential failure modes. And it's not hard work, but it feels unnecessary to people who are really keen on chomping out features. And I think advocating for time to plan for failure modes, particularly as you kind of go through your life cycle as a startup. I think at a certain time in the sort of early stages of startup life, you have few enough customers and you're gung-ho enough that actually just sort of spending all your time on churning out features and trying to hit the market is probably a better use of time. Once you've developed that product market fit and you're raising money to sort of productionize that stuff, these are the types of things that you need to be doing, really spending time on thinking about resilience and availability. So don't worry about doing this too early if you're still trying to figure out what your product looks like. Once you know what your product looks like, you should be spending time on this stuff, and a lot of teams kind of don't. And I think it's important. Planning for disaster recovery is also an area of concern. Of the 200 workloads we reviewed, 79 of those have high risks in this area. So only a third of teams in this data actually know what their objectives are for downtime and data loss. If you're not having conversations in your teams about what is our recovery time and point objectives, so in the event of the service going down, how long are we prepared for it to be down for? That's your recovery time objective. So you might say, this needs to be back up and running within an hour, say. You might, depending on the type of workload you have, be okay with it being down for 24 hours or a week. It's really business dependent, and these are business conversations to have. And the recovery point objective is about how much data are we prepared to lose in the event of catastrophic failure. That is to say, do we have to keep every single transaction, every single piece of data? And there are some business areas where that is necessary. Banking is a good example of that. But the cost of building a system that has zero data loss is exceptionally high. And so when you're looking at those things in terms of trade-offs, it might be okay for you to lose an hour of transactions. It might be okay for you to lose a day of transactions. Those recovery objectives will then inform how you design the services to meet them and give you a goal to measure against. Only a third of teams are actually thinking about this stuff. Don't be the 2/3 essentially. And teams are not really testing disaster recovery. That's again, once you're sort of in a mode where you're transacting real money and you have a real product, then testing disaster recovery scenarios is an important thing to spend some time on as you sort of grow up operationally in that regard. So yeah, generally we found teams are bad at thinking about failure modes. A lot of teams not really considering business requirements around failure. There's no real risk analysis. I think there's a sort of optimistic assumption that things won't ever fail. And in 2020, a lot of the cloud services are really reliable. That certainly the likelihood of failure or the pain of the impact of failure is definitely lower than it was when we were building systems 10, 20 years ago. But you can still fail, and so you should have a plan for dealing with that. Most teams not documenting things at all. Please do try and write stuff down for other people. And there's almost no attempt anywhere to rehearse outages and sort of practice what happens in the event of a failure, which means when you do have a failure, you've no idea what you're doing. You are kind of making it up on the spot. And that sort of thing is what's going to lengthen your mean time to recovery. You not rehearsing outages is the sort of thing that leads you to make a bad mistake and cause things to be worse, and maybe sort of turn a 1-hour outage into a 24-hour outage. Some of you might remember the GitLab outage of a few years ago. That was bad disaster recovery planning. They did some database activity during that outage that made everything way worse, and had to reconstruct a lot of stuff by hand. And you don't want to be that team in the public eye, spending your time piecing together databases from old backups and kind of copies of data lying around on thumb drives and so forth. Don't be those people. Performance efficiency, pillar 4. Most teams are okay at this, actually. The main areas around performance are choosing the right components. So making sure that you are choosing a data services that match the type of data you're storing, choosing an appropriate EC2 instance type for the type of processing you're doing. So one good example of this is understanding instance types. So many of you are probably using the sort of T2 and T3 instance classes because there is a reason they're cheap. They're designed for bursty workloads, and sort of build up what's called a token bucket of tokens that you can use to pay for burst CPU. And if you're consistently using medium to high CPU on those instances, you can exhaust those buckets, and the performance gets very confusing, particularly if you're running them in auto-scaling groups. So knowing the characteristics of each instance type and choosing appropriately for your workload is an important thing to do. Another consideration is choosing a database type to match the type of data you're storing. So if you're storing relational data, choosing a relational database, usually a good idea. If your data is graph shaped, then choosing a graph database like Neptune. Those sorts of choices, architectural choices, matching infrastructure components to workload is teams are mostly doing okay at, but sometimes don't quite go all the way. Configuring things correctly as well. So understanding that there are things that you can tune in those services to ensure that you are performing at the level that you should be, and then periodically reviewing those choices. There are a couple of questions in the WellArchitected framework about how frequently you're looking at new AWS services, and often teams are sort of not. It's one of the things that we do for clients is kind of let them know of new things coming out that they might want to think about, because often something that you are using EC2 instances for might ultimately become a managed service that you can adopt, which will solve some performance problems or make some of the operational pain go away. And then monitoring for performance. So we operational excellence also covers monitoring. Monitoring sort of runs through all of these areas really. Knowing what your application is doing and knowing what your infrastructure is doing from a performance perspective is important. So when we're talking about choice of compute, we're not just talking about instance types. We might also be thinking about, are we thinking about Kubernetes? How about Fargate? Maybe Lambda is a right approach. There are trade-offs at each of those each of those sort of areas. It's less effort to run Lambda than it is to run EC2 instances, at least as far as patching and sort of maintenance of an operating system is concerned. But it is a strongly opinionated platform, and so you might not necessarily get on with those opinions, depending on how you're doing it. So sort of looking at those things appropriately, and not just thinking about workload in terms of your application requirements, but also your people. If you're adopting Kubernetes, you probably need your people to understand what Kubernetes is, and maybe not just Johnny DevOps who's there on a freelance basis, who's going to build that and then just disappear. Choosing appropriately for your team as well as for your workload is an important consideration. I've mentioned choosing a good data storage option to match the type of data that you are storing. Below the line there are the sort of the non-AWS service alternatives, although actually there is now a managed Cassandra for AWS. So this is obviously out of date. I need to update this slide. But there is almost always an AWS solution to the problem that you have, and adopting that will probably improve your life as far as performance and operation is concerned. Cost optimization is the last pillar. Yes, I've spelt it with an S in this slide. That's not how to put it in the WellArchitected docs, because they're from over the pond. I insist. Teams are mostly not evaluating new services in a planned way, and that has cost implications. So keeping on top of the things that AWS are releasing as far as services are concerned can have cost implications. The main areas in the cost pillar are governance. So in a larger organization, understanding and controlling how your spend is happening on the platform. In startups, you're probably not too worried about this. Particularly not if you've got, say, AWS Activate credits, you've got 100 grand in the bank that isn't actually costing you anything. Although you probably want to be thinking about that for when those credits run out. Larger teams occasionally have sort of no real control over spend. So you'll have developers spinning up huge Hadoop clusters that cost thousands of dollars a month, and running with no data in them just because it was a kind of a Friday afternoon experiment once that wasn't torn down. So governance around that is worth considering as you grow. Monitoring for cost usage. If you can do that early on in your journey, you'll have a better time. So tagging resources to understand what they're used for, so you can look at the cost explorer and see that this particular product feature is costing you this amount of money, or this particular BI setup is costing this amount of money is an interesting thing to do. There will always come a time when your bean counters come and say, can we reduce our spend? You better off getting out in front of it before that happens. Turning off stuff that isn't being used is a surprisingly common thing that people don't do. We did some work with a customer who had maybe 3 Elasticsearch clusters running in development environments that weren't being used. I think we saved them sort of somewhere between $6,000 and $10,000 a month just by turning those off. So thinking about life cycle of stuff and turning things off when they're not being used anymore. There are tools to help you with this, things like Cloud Custodian. You can set up a tagging policy so that your teams are required to add particular cost-related tags to everything they spin up. Cloud Custodian can report on things that don't have those tags, or turn them off. In some of the work we did with Expedia, we implemented that so that teams were required to demonstrate what they were spending money on, or their resources would just disappear. You'd be surprised how quickly that was adopted as a practice, given that. Matching supply with demand. So the main kind of cloud economic story here is that you don't have to pay for resources you are not using. So using auto scaling, using things like Lambda to make sure that you are only using the compute that you need at any one time for the requests that you're getting is a really good way of keeping your costs in check. And being aware of pricing models, so reserved instance spend, savings plans, those sorts of things are all ways of saving money with various trade-offs. If you know that you have a committed amount of compute requirement over a period of time, you can pay up front to offset the cost of that. And save up to sort of 60% of your compute costs. So those are things to think about. So that's all of the 5 pillars. What's next from here? Well, you should probably read the white papers. They're not long. They're pretty well written. There's some good stuff in there. You may not agree with all of it. I don't agree with all of it, but it's worth looking at and seeing what AWS think of as best practice. You can run your own review. There's a tool, the WellArchitected Review tool exists in the console, but really you get way more benefit from the review process if you engage with a well-architected partner. And I hope that after today you consider doing that with us. There are funding programs available. So if you have a workload and we review that workload, and you go on to engage us to help make changes to improve that workload, there are $5,000 of funding available to do that. So we would bill you in cash for our time and expertise. You would get AWS credits back in return to cover that funding. That funding works on a per workload basis. So if you are running, for example, a web application and a big data platform to feed data into it, or to kind of report on the usage of the platform. Those are 2 separate workloads, and so those funding credits are available twice in that case. We have in some cases claimed tens of versions of these credits for a single organization. So there's definitely economic value to doing that. I think the takeaway that you should sort of leave with today is that most teams are better at building platforms than they are at securing or running them, and there is a high chance that you are one of those teams. And by engaging with us or any other partner, but preferably us, then you stand a good chance of getting out in front of some problems that might cause you real difficulty in future. So you can talk to us about consultancy. We do sort of whiteboard or kind of talk and chalk style traditional consultancy. We also have training offerings as part of our support and learning package. You can subscribe on a monthly basis to have access to our team on Slack, to answer your questions about AWS throughout the day, to book surgery hours, and to join monthly training courses where we tend to cover the things that are done badly by teams in WellArchitected. So things like IAM, foundational things around IAM, we run regularly because that's an important thing for people to know. We can also customize training to your particular needs. So do talk to us if you would like to skill up your team in these areas. We obviously are a well-architected partner. We can run well-architected reviews for you. We sort of book about 12 a month or so at the moment, and we'd love to review your workload and help you make some good decisions. And if you're migrating from another platform or building a new infrastructure, then we can help there as well. So basically, anything that you're doing in the AWS landscape, it's very likely we can help. It's very likely we've done it before, and it's very likely we'll do a good job of it for you. So if you are interested in getting a well-architected review, then you can use this link here. You'll get this link in your email tomorrow as well in the follow-up that Zoom will send. You can, from that page, read a little more about it, or actually go ahead and book a review straight off. Those reviews are about 4 hours. We have a number of slots available in the coming weeks. You can just go in there and say, I'd like a review on this date, and either Steve, who's also on the call, or Mike, or one of the other members of my team will do that with you. If you're a CTO, a CEO, or a sort of decision maker for your business in general, you might be interested in Breakfast Ops, which is a monthly discussion that we run. Previously in our offices in London Bridge, but at the moment on Zoom, like everything else. We generally choose a topic on operations or infrastructure for discussion. It's usually other CTOs, other kind of engineering decision makers. There's usually some really good insights to be gleaned from how other people are doing the types of things that you might be having problems with. If you are in that demographic and you'd like to join Breakfast Ops, please drop me an email after this and I'll make sure you're on the list. I believe the next one is scheduled for the 20th of May, but don't hold me to that because I don't have my calendar open in front of me. But it will be sort of later in May. Yeah, we did one not too long ago. Cool. So we're at the Q&A section. If you have any questions about anything I've covered today, whether that's sort of pillar specific or general well-architected or about the funding credits or anything of that nature, please do hit the Q&A button at the bottom of your screen and type the question in there. We'll hang around for a few minutes to answer anything that you have to ask. Should give you another 30 seconds to hit enter on anything you're currently writing before assuming that actually nobody has any questions. Okay, so Fox asks, what is the most common architectural mistake on AWS? I will answer that. So the data that we have shows that most of the mistakes that people made are not necessarily architectural. They're more broader than that. So the sort of not doing a good job of writing down documentation or run books or those sorts of things. In terms of actual architecture, I guess the things that we've seen are sizing things too big. So rather than thinking about auto scaling or being sort of smart about elastic capacity, just making everything really big and hoping that that is sufficient, which is not necessarily a mistake so much. I guess it's old thinking. It's what we used to do in the data center world, because buying new hardware took 6 weeks, which is infuriating. But it has cost implications, and that's the main problem. The other mistakes that we see in sort of technical terms, the IAM story is generally pretty bad. So security in general is something that teams need to improve at. Often the baking of credentials into config files, or having everybody on the team having higher levels of permission they need on the platform is a pretty regular mistake. But in general, architecturally, people are doing all right. I think the source of a lot of problems is when people come new to the platform. AWS is big, right? There's a lot of stuff there. It's like a big bag of Lego bricks, and you are expected to know sort of which way to plug those bricks correctly first time, which is sort of why WellArchitected helps and why working with an experienced partner helps. Because a lot of the blog posts that you would read as a sort of beginner coming to the platform are often optimized for what I call a mean time to hello world. So can I get something up and running that looks like it works really quickly? And the way that those sorts of blog posts do that is to brush over loads of the detail and put everything in a public network and stick a public IP address on it, and add IAM policies that have wildcards all over it. So it looks like it works, and you're serving applications and in theory kind of generating user value from that. But you are doing things that eventually will hurt. So I would say not fully spending the time to kind of understand the parts of the platform that you're going to be using is the biggest cause of that mistake, I guess. Thanks for your question, Fox. Another question from Fox. Regards to serverless architecture, Lambda authorization, which option works better? Set up an IAM role for each role and SSTM role on top of a Lambda. Use generic Lambda execution role and write authorization in your code. That is a good question, and one which I don't feel particularly that I can answer. If you like to pose that question in more detail, I will arrange for one of my team to have a chat with you after this. I think there are probably pros and cons to each one of those approaches. I haven't personally done enough Lambda to be able to comment. My job is primarily spreadsheets, email, and webinars these days. But one of my team definitely be able to answer that more accurately than I. Cool. All right. Well, if you have further questions, you can email me. My email address is john@scalefactory.com, which is the email address that you'll get some comms from tomorrow when Zoom sends out its thanks for coming reminder. You should gain access to a recording of this at a link provided by email as well. It's the first time I've turned that feature on in Zoom, so hopefully it works. If that doesn't work and you'd like to see a recording, if you haven't had a link by sort of the end of tomorrow, please drop me a line. I'll make sure that I share that with you. And if you'd like to copy these slides, I can share that as well. We have another couple of webinars coming up in the near future. I will make sure that you get details of those. Thanks for your time. Thanks for your attention. And hopefully this has given you a better understanding of what WellArchitected is, why it might be useful to you, and of course, crucially, why you would like to engage the Scale Factory to review your workload for you. So thanks very much. I don't know if anybody from AWS has anything that they would like to add before we close out today.
No, just thanks everybody for attending. We're obviously really proud of the WellArchitected Review partnership program that we had, and very proud to be partnering with great partners such as the Scale Factory. As Josh mentioned, to open up the call, if you do have any questions, please reach out to your AWS account manager, and we can kind of help from there. Or if they're obviously WellArchitected Review specific inquiries, obviously John's posted the link to go from there. So appreciate everyone's time today, and thanks very much for joining. Looking forward to running a few more webinars like this, and yeah, thanks everybody for joining.
Thanks, Tom. I've just seen actually there's a question from James in the chat, which I didn't see until I closed my Keynote application down. James asks, for startups in a pre-production state of product development, how much of a disadvantage is it to do the WellArchitected review too early given some of the categories? I don't actually think there is a too early. I think we've done WellArchitected reviews for teams who haven't built their application yet, or are thinking about starting a migration from another platform. I think doing it early and talking in hypotheticals is still a good teaching tool. I think it'll sort of cause you to avoid some fairly common mistakes that a lot of businesses make. What you might want to do, so because there's the funding program involved, what you might find is it doesn't make sense for you to use the funding credits until later, particularly if for example you're an AWS Activate user. So you might Activate is a program where you get access to funding credits from AWS, because your investors are aligned with AWS in a partnership way. So I think there are up to about $100,000 available from Activate, depending on your funding situation. If you don't have funding from an Activate partner, there's still $1,000 available to just claim. But it's worth, I think, not doing that if you are thinking you might later be funded by an Activate partner, because I think that might invalidate your ability to claim the larger amounts later. But if you have Activate credits, then there's not a lot of point claiming WellArchitected credits as well, depending on how much Activate credit you're sat on. You might find that all of those credits expire before you get the benefit of them. So Activate credits have a 12-month lifespan. What you might choose to do is do WellArchitected review with us early, so you get the benefit of the sort of the learning and the conversations around how you might go about doing that. If you're going to engage us, then pay actual cash for that, and then at the end of when your Activate credits run out, then we come back and do another review. We do the credit claim process and add that $5,000 there. So the only reason you might want to delay some of the WellArchitected consideration is based on your funding position. But there is genuinely benefit from doing well-architected early, baking it into your practice from day one, and using that to build your operational roadmap. So that at least if you're not doing things like game day planning around your availability and so forth, you have intentionally chosen not to, rather than just not knowing that you needed to. And I think sort of being one of the benefits of consultancy, consultancy has two benefits, right? You're either answering questions that a customer already has, or you are shining a light on areas where the customer didn't know that they had questions. And WellArchitected is a good example of both of those value offerings. So if you go into your kind of startup build knowing that there are some things that you don't yet know, but knowing that there is probably going to be a time when you have to think about them, then they can go in your roadmap and you can come back to us at a point that is more appropriate, maybe after an A round or a B round, or you're ready to spend some money on kind of doing it properly, and we can help at that point. So yeah, hopefully that's useful, James. Thanks for your question. Do drop me a line if that wasn't clear. Cool. All right, everyone. Thanks for joining. We will speak with you soon. Stay safe, be lucky. We'll catch up in future.
Thanks, everyone.